Hello guys and welcome back to the channel. I've got another probability video for you guys encompassing some questions that I found on my own as well as some of the questions that you guys have been sending in. So thank you as always for doing that. Okay, so a weighted six-sided dice is thrown. The dice is numbered 1 to 6. It's weighted so the chance of getting a prime number is twice as great as the other numbers. So you've got 1, 2, 3, 4, 5, 6. Remember, just a quick definition for what a prime number is. A prime number is a number that has two individual factors, okay, that but are both divisible, that go into that number essentially, but the two numbers have to be separate, they have to be different. So 1 isn't a prime number because its factors are 1 and 1, but they're the same thing. Okay, but 2 would be a prime number despite it being even, because its factors are 2 and 1, and there's only 2 of them. Okay, so a prime number only has 2 factors, both of which have to be different as well. Okay, so the primes are these 3 here, and so the chance of getting a prime number is twice as great as the other numbers. Okay, so the chance of getting a prime number is twice as great as the other numbers. So what's the probability expressed as a fraction of rolling a number greater than or including a 4? So chance of getting a prime number is twice as great as the others. So in total we have, if we add up all of these x's, so 3x, 5x, 6x, 7x, 8x, so it's 9x in total. So the probability therefore of rolling a number, so 9x is the total amount of chance that we have, I guess. So the probability of rolling a number greater than or including a 4 is going to be x plus 2x plus x, which is 4x, divided by 9x, which is going to be 4 ninths. Okay, so not too bad of a question. So the answer here is 4 ninths. Okay. Cool. So on to the next one. So when flipped, a fair coin has an equal probability of coming up heads or tails. I flip a fair coin 4 times in a row. The first time I flip the coin, it comes up heads. Is there a 1/8 probability of the coin coming up tails at least once in the 4 flips? Okay. So these questions, whenever you see the at least once, you should kind of think about an idea here. So it's really hard to calculate probabilities of at least once because because if you think about it, for example, it could be that it comes up tails once in the first flip. It could be that it comes up tails in the second flip. It could be that it comes up tails in the third flip. It could be that it comes up tails in the second or third. It could be it comes up tails in the first or second. Basically, it's unlimited amount of possibilities, and it's really hard to do it. So what I would do is instead calculate the probability of it coming up all heads, so no tails at all, and then do 1 minus that. Okay, so the first time we know it's heads for sure. Okay, so then we're just worried about the other 3 probabilities. So therefore, so this is the probability of that being heads is 1. Then being heads again, heads again, heads again would be a half times a half times a half. Okay, so then this is going to be 1/8. So that's the probability of getting all heads, basically. Okay, so the probability of getting at least 1 tails is going to be 1 minus an 8th, which is 7/8. So is there a 1/8 probability of the coin coming up tails at least once in the 4 flips? I'd say no, it's 7/8. Okay. So, on to the next question. A fair 6-sided dice has 3 additional dots painted on each of the faces, 1, 2, and 3 dots. The die is then rolled twice. Okay, so it has the chance of rolling a double 6 increased by a factor of 2. So instead of it being 1, 2, 3, 4, 5, 6, the dice is now, so you add 3 to each of these, so it becomes 4, 5, 6, 4, 5, 6. So the chance of rolling a double 6, therefore, using the old die is just a 6 times a 6, which is 1/36. And with the new die, it's going to be the chance of rolling a 6 on the first go is 2/6. The chance of rolling a 6 on the second go is 2/6. And just as a quick remember, the probability of multiple events occurring, so rolling a double 6, is each one occurring individually multiplied together. So 4/36, 1/36. Okay, so has the chance of rolling a double 6 increased by a factor of 2? I would say no. Okay, it's increased by a factor of 4. Okay, happy with that? So, on to the next question. So this is another classic question. So I think I may have even covered a question like this before in another video, but just to kind of like reiterate. So with these questions, the idea here is, so if Aiden is winning 4-1, he has over a 50% chance of winning the overall game. So it says Thomas has a 2/3 chance of winning each game they play, the first to reach 5 wins. So the point here is, Aiden is winning 4-1. So if Aiden can just win the next game, right? And then he'll win. So the score overall will be 5-1. Thomas could win the next game, then Aiden could win. Then that would be 5-2. Then Thomas could win 2, but then Aiden could win the third, and Aiden would still win comfortably. And you can see there are many possibilities that can occur, except for the last one, in which, sorry, wouldn't be 5-4, it would be, technically it would be 4-5 to Thomas, and Thomas would win. Okay, so that's the only possibility in which Aidan loses. So the point here is, instead of working out the individual probabilities for the 4 areas where Aidan wins, it's way faster to just work out the probability for the 1 area where Aidan loses and then do 1 minus. Okay, so this is a really useful tool that we have to get used to being able to do. So the probability of Aidan therefore losing is the probability of Thomas winning every game, which is going to be 2/3 times 2/3 times 2/3 times 2/3, which is 4, 8, 16 over 9, 27, 81. So then 1 minus 16 over 81 is 65 over 81. Okay, so 81 minus 16, just confirming, yeah. So if Aidan is winning 4-1, he has over a 50% chance of winning the overall game. I would say that's true, yes. Okay, and his chance is actually this here. Okay, and the reason why is, I guess the best reason why, is because Aidan only has to win 1 of these 4 games. Cool. And so just as a quick kind of as main point, so someone said that they weren't sure about when to multiply and when to add. So it's a little bit tricky, but for multiplication, you only multiply in probabilities if there's individual events happening and you're asked to calculate the sum of more than 1 event happening. So here, for example, it's like, if we were calculating 4 Thomas wins, you'd have to calculate the probability of each individual Thomas win multiplied together. Okay, but then we would add up all of these probabilities if we were working, but then we added up these, or we would have added them up if we worked it out, if we wanted to work out the overall chance of Aidan winning. So, like, it's hard to say with the adding. I think it's definitely much more easier to think about the multiplying, but with the multiplication, it's always when you have more than 1 event happening. With the adding, there's no such set rule as it. It's more just kind of like more intuitive almost in a way. I know that's not necessarily the exact answer that you wanted, but I hope it still makes somewhat sense. Okay, cool. Okay, so there are 10 children queuing at Santa's grotto. Each child is given a gift at random, either a toy car or a toy airplane. There's 8 toy cars, 2 toy airplanes. The first 5 children leave the grotto with unwrapped gifts. Could the probability that the 6th child will receive a toy car be 0.8? So that means there's 5 toys left over, right? And it's going to be toy cars and toy planes. So is the probability the 6th child will receive a toy car be 0.8? Well, can you do that? 5 times 0.8 is 4. So there could be 4 toy cars, and since we have 5 in total, 1 toy airplane. So actually this is a possibility. Do you see? So this is a possibility. Because it doesn't say is the probability, it's could it. So I would say yes. Out of these 2 options, B is the one that makes sense. It says the probability is likely to have shifted. This could still be 4 cars, 1 airplane. Yeah. So it's likely that, you know, it's not necessarily 4 and 1, that it's one of the other combinations, but this is still a possibility. So whereas if you'd done this calculation, for example, and it gave you like a number that wasn't possible, so if you did like 5 times 0.8 or whatever the number was, and it gave you something like 3.6 toy cars, like then it wouldn't be possible. Okay, does that make sense? So once again, it's just with a bit of experience that you can kind of do a question like this. So we've gone through a couple of probability questions here, so hopefully this was helpful. So I decided to waffle a little bit less and just get through some more questions this time. So thank you so much, guys, for watching as always, and thank you for all of the support. One thing that I know is really crucial is you guys will be doing your Ucat very soon, so please don't stay up too late. Really important. Make sure to eat, sleep, drink well, and make sure to also let us know how you're getting on as well. Okay, so take